dy by dx is called the slope of tangent to the curve y is equal to f of x. Usually d by dt will represent the rate of change with respect to time t seconds. You know the area of a circle is given by area is equal to pi r square when the time t is equal to 2 seconds. This is a very simple problem. Differentiate it and substitute the value of t. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very important chapter, that is application of derivatives. So this is very important chapter. In this session you are going to study regarding the rate measure and increasing decreasing function and maxima and minima of the function. Now let us come to the weightage for this chapter. In this chapter you will get one 2-mark question and two 3-mark question. Totally the weightage for this chapter is 8 marks. So you will get one 2-mark question, that is 2 mark, and 3 marks question, 2 questions, that is 6. Totally you will get 8 marks from this chapter, and very easiest chapter. Now let us come to the first concept we are going to study in this chapter is rate measure, that is rate of change of a quantity. Rate measure, rate of change. Usually d by dt will represent the rate of change with respect to time t seconds. Rate of change. Suppose if s is the distance traveled or if s is the displacement of a particle in time t second, then the rate of change of displacement is given by ds by dt. You know the rate of change of displacement in physics is nothing but the velocity. So the velocity of a particle is given by ds by dt. If you differentiate the given equation one time, and you will get the velocity. So if s is the distance traveled, if s is the displacement of the particle, then the rate of change of displacement is denoted as ds by dt. This is called the velocity. The rate of change of displacement is called the velocity. Now suppose if we differentiate this velocity, if we differentiate this displacement again, once again, that is second derivative, d by dt of ds by dt, that is nothing but d by dt of velocity. So if we differentiate the velocity, what you will get, this is d square s by dt square, that is nothing but dv by dt is equal to acceleration. So if you differentiate once again, you will get the acceleration. So d by dt of ds by dt is equal to d square s by dt square is called as the acceleration a, that is nothing but dv by dt. So in general, the velocity is equal to ds by dt. ds by dt is called the velocity, and the acceleration is equal to dv by dt. dv by dt is called as the acceleration. So in general, if you differentiate one time, you will get the velocity. If you do one more differentiation, the double differentiation, if you differentiate once again, d square s by dt square will give the acceleration. Now suppose if the velocity is equal to 0, if dv by dt is equal to 0, rate of change of displacement is 0, means the particle is under rest. Now suppose if the acceleration is equal to 0, dv by dt is equal to 0, that is rate of change of velocity is equal to 0, that is acceleration is equal to 0, means then the particle is moving with uniform velocity. So the particle is moving with uniform velocity. Now let us, based on this concept, let us come to a problem. Let us come to the first problem based on the properties of circles. Now problems based on circles. Let us consider a circle with O as center and R is the radius. You know the area of a circle is given by area is equal to pi r square, and circumference of the circle is given by 2 pi r, where r is the radius of the circle. So if r is the radius of a circle, then the area of a circle is given by pi r square, and the circumference of the circle is equal to 2 pi r. Based on these two formulas, area as well as the circumference of the circle, let us consider the problems. Now let us come to the first problem. Find the rate of change of area, rate of change of area of a circle with respect to the radius r. Rate of change of area. So what is required to determine? Rate of change of area means dA by dt with respect to time is t, and dA by dt is the rate of change with respect to time t. Okay. Now suppose here the rate of change of area of a circle with respect to r is given by is nothing but dA by dr. So rate of change of area with respect to time is denoted as dA by dt. Rate of change of area with respect to radius is denoted as dr by dt. Now what is the problem given? Find the rate of change of area of a circle with respect to radius. This is to be determined. This is the question mark. Now what is given? When r is equal to 3 centimeters and r is equal to 4 centimeters. Now we know that the area of a circle is equal to pi r square. Now differentiating with respect to the radius r, then what you will get? dA by dr is equal to pi into differentiation of r square is 2r. We are differentiating with respect to r. So therefore dA by dr is equal to pi into 2r. Now case number 1, if A is equal to 3 centimeters, then the area dA by dr is equal to pi into 2 into 3, that is equal to 6 pi. Area, so centimeter square, the area of the circle when radius is equal to 3 centimeters with respect to the change in radius is given by 6 centimeters square. Now when r is equal to 4 centimeters, then what we will get? dA by dr at r is equal to 4 is pi into 2 into 4, that's equal to 8 pi centimeters square. That's it. So this is the area. So when r is equal to 3 centimeters, the area is 6 pi. When r is equal to 4 centimeters, the area is equal to 8 pi centimeters square. That's it. This is the required answer for the given problem. Hope you followed. Okay. Now let us come to the next problem. The radius of a circle is increasing uniformly at the rate of 3 centimeters per second. Find the rate at which the area of the circle is increasing when the radius is 10 centimeters. Here what is given? The radius of a circle. Now let us write down the formula first. Area of a circle is pi r square. The radius of a circle is increasing uniformly at the rate of 3 centimeters per second. That is the radius dr by dt is given, that is equal to 3 centimeters per second. The rate of change of radius with respect to time is given, dr by dt is equal to 3 centimeters. Find the rate at which the area of a circle is increasing. What is required to find is dA by dt. When r is equal to 10 centimeters. That's it. Okay. Now what is given? Area is equal to pi r square. Now area is equal to pi r square. Differentiate with respect to t. What is required to find is dA by dt. Differentiate with respect to t. dA by dt is equal to pi into, we are differentiating r with respect to t, therefore this is 2r into dr by dt. Now substitute the values. Pi into 2 into r is 10 centimeters and dr by dt is equal to 3 centimeters. That is pi into 10 into 3 is 30 into 2 is 60. So this is equal to 60 pi. Area, what is the unit given? Centimeter square per second. The area is equal to centimeter square per second. That's it. See here, what is given? dr by dt, rate of change of radius with respect to time is 3 centimeters and radius is equal to 10 centimeters. What is required to find is the rate of change of area of a circle with respect to the time. So dA by dt is to be determined. Area is equal to pi r square. Differentiate with respect to t. Pi into derivative of r square is 2r into dr by dt. Pi into 2 into r is 10. Dr by dt is 3. So that is nothing but 10 into 3 into 2 is 60 pi centimeter square per second is the required answer. Okay. Hope you followed. Very simple for 3 marks. Now let us come to the next problem. The radius of a circle is increasing at the rate of 0.7 centimeters per second. What is the rate of increase of the circumference of the circle? So here circumference of the circle. What is the formula for circumference of the circle? In the beginning itself, I have given the formula for circumference of the circle is 2 pi r. Using this, we can get the answer. That's it. Very simple. See here, the radius of a circle is increasing at the rate of rate of change of radius. Now, what is given here? Given that dr by dt, rate of change of radius. The radius of a circle is increasing at the rate of 0.7 centimeters per second. That means dr by dt is equal to 0.7 centimeters. What is the rate of increase of the circumference of the circle? dc by dt is equal to question mark. That's it. Now, what is the formula for circumference of the circle? So, the circumference of the circle is equal to circumference of the circle, let us call it as C, is equal to 2 pi r. Differentiate with respect to t, that's it. Differentiating with respect to t, what we will get? dc by dt is equal to 2 pi constant. Differentiation of r with respect to t is dr by dt. Now, substitute the value 2 pi into what is dr by dt? 0.7, that's equal to 0.7 into 2 is 1.4 times pi. Since this is the circumference, this is centimeter square per second. So, write down the particular area for unit for this particular circumference. That's it. Now, write down the particular area. What is the area unit here? It is centimeters per second. Write down the particular unit for this. Listen to me. Listen. Since what is given? dr by dt is equal to 0.7 centimeters. What is required to find is dc by dt, where c is the circumference of the circle. The circumference of the circle is given by 2 pi r. Differentiate with respect to t. dc by dt is equal to 2 pi constant. Derivative of r with respect to t is dr by dt. Now, just substitute the value of dr by dt, that is 0.7. 2 pi into 0.7 is equal to 1.4 pi centimeters per second. The rate of change of circumference, the increase in the circumference of the circle is given by dc by dt is equal to 1.4 pi centimeters per second is the unit. Okay. Next, let us come to the next problem. Now, here these are very important type of problems. The distance s feet traveled by a particle in time t seconds is given by the equation s is equal to t cube minus 6t square plus 15t plus 2. Find when the acceleration is 0. So, what is required to find? We have to find when the acceleration is equal to 0. Now, what is given first here? S is equal to, the given equation is t cube minus 6t square plus 15t plus 2. Let us represent this as equation number 1. Differentiate with respect to t. Differentiating with respect to t. If you differentiate this, what you will get? So, you will get ds by dt is equal to 3t square minus 6 2s are 12t plus 15. So, differentiation of t cube is 3t square, 6 constant, t square is 2t, 2 into 6 is 12, 15 into derivative of t is 1 plus 2 constant 0. Differentiate again. Differentiating again with respect to t. So, then what happens? D square s by dt square, you will get second derivative. Derivative of t square is 2t, 2 into 3 is 6t minus 12. Let us represent these as equation number 2 and 3. Now, here what is the problem? Actually, what is required to find is the time. The distance s feet traveled by the particle in time t second is given by s is equal to t cube minus 6t square plus 12t plus 2. Find the time when the acceleration is 0. Now, to find the time, let us differentiate this. So, what is required to find is t. T is equal to the required quantity. This is to be determined when the acceleration is equal to 0. When acceleration is equal to 0, what is required to find is the time t. Now, here when acceleration is equal to 0, that is d square s by dt square is equal to 0. That means this equation 6t minus 12 is equal to 0, 6t is equal to 12, t is equal to 12 by 6, that's equal to 2. So, therefore, t is equal to 2. At time t is equal to 2 seconds, the acceleration is equal to 0. This is the given answer. So, actually what is required to find here is the time when the acceleration is equal to 0. Just differentiate it and get the value, that's it. Okay. Now, let us come to the next problem, the similar type problem. The displacement s of a particle a time t is given by s is equal to t cube minus 5t square plus 4t minus 3. Find first the time when the acceleration is 12 feet per second square. In the first problem, when the acceleration is 0, we have determined the time taken. Here, when the acceleration is equal to 12 feet per second square, we are going to find the time taken. Similarly, the velocity and displacement at that particular time. Okay. Now, first find out t, then find out the velocity and acceleration at that particular value of t. Now, what is given? S is equal to t cube minus 5t square plus 4t minus 3. Let us represent this as equation number 1. Differentiating with respect to t. If we differentiate with respect to t, ds by dt is equal to 3t square minus 5 2s are 10t plus 4. Let us represent this as equation number 2. Differentiate this again. Again differentiate with respect to t. Again with respect to t. Then what we will get? D square s by dt square is equal to 60 minus 10. Now, this is equation number 3. Now, what is given? The time when the acceleration is 12 feet. Given first condition. Given that acceleration is equal to, what is the acceleration? 14 feet. Now, equate it. From equation number 3, you will get the acceleration 60 minus 10 is equal to 14. 60 is equal to 10 plus 14, 60 is equal to 24, therefore t is equal to 24 by 6, that is nothing but 4, t is equal to 4 seconds, the time taken is 4 seconds, okay. See here, when the acceleration is equal to 14 feet, 60 minus 10 is equal to 14, 60 is equal to 10 plus 14 is 24, so therefore t is equal to 24 by 6, 6 4s are 24, t is equal to 4 seconds. Okay. Now, what is required to find? The velocity and the displacement at that time. So, at t is equal to 4, find out the velocity and the displacement. Now, at time t is equal to 4 seconds. Now, come to the first one, velocity. Velocity v is equal to ds by dt. That is equal to, from equation number 2, from 2, 3 into, this is from equation number 2. So, that is 3 into t square, 4 square minus 10t, 10 into t is 4 plus 4. Simplify this. 3 into 4 square is 16, 10 4s are 40 plus 4. Now, this can be written as 16 into 3 is 48 minus 40 plus 4, that is 48 plus 4, 48 plus 4 is 52 minus 40, 52 minus 40 is equal to 12. So, velocity is equal to 12 meters per second. What is the unit they have given? So, unit is not given, yes, feet per second. Velocity is equal to 12. Now, therefore, the velocity is equal to 12 feet per second. This is the velocity. To find the displacement, just substitute the value of t in this given equation. So, from 1, s is equal to, what is s? That is t cube minus 5t square plus 4t minus 3. Put the value of t, t is equal to 4, that is it. So, this is 4 cube minus 5 into 4 square plus 4 into 4 minus 3. 4 4s are 16, 16 4s are 64 minus 5 into 16 plus 16 minus 3. So, this is equal to 64 minus 16 into 5 is 80 plus 16 minus 3 is plus 13. Now, simplify this. 64 plus 13. Let us simplify this. This is 80. Okay. 64, 6 plus 4 plus 3 is 7. 6 plus 1 is 7. 77 minus 80. 77 minus 80 is equal to minus 3. Minus 3 feet. The answer is minus 3. So, the required answer is minus 3 feet is the displacement. Now, let us come to the next problem. A particle moves according to the law S is equal to t cube plus at square plus bt, find a and b if the initial velocity is 5 unit and when time t is equal to 1 second, it is moving with a velocity which is 4 times its initial velocity. This is very important problem indeed. So, what is required to find is a particle moves according to the law is given by S is equal to t cube plus at square plus bt. Find a and b. So, a and b is required to find. So, a and b is to be determined here. Then what is the condition? The initial velocity is 5 unit and when time t is equal to 1 second, it is moving with a velocity which is 4 times its initial velocity. Now, first find out the derivative for this. What is given? S is equal to t cube plus a t square plus b into t. Let us represent this as equation number 1, differentiating with respect to t. So, if you differentiate with respect to t, ds by dt is equal to 3t square plus a into differentiation of t square is 2t plus b. Differentiate again, differentiating with respect to t, again what we will get? D square s by dt square is equal to 3 2s are 6 plus derivative of t is 1, 2a. Now, 6t plus 2a. Now, what is the condition? Find a and b if the initial velocity is 5 unit. When time t is equal to 0, given, yes, first condition, when t initial velocity, time t is equal to 0, what is the initial velocity? Velocity is equal to 5. So, substitute here, what is this? Velocity and this is acceleration. So, 3t square plus 2at plus b is equal to 5. Now, substitute the value of t as 0. This is 0 plus b is equal to 5. So, therefore, you will get the value of b as 5. That's it. This is the first value. See here what is given? Initially the velocity. So, the initial velocity is 5 units. Initial velocity is 5 units means at time t is equal to 0, the initial velocity is 5. Substitute here. Since b is equal to 5, we know velocity 3t square plus 2at plus b, put t is equal to 0, then you will get b is equal to 5. That is the first answer. Okay. Now, second condition. At time t is equal to 1 second, it is moving with a velocity which is 4 times the initial velocity. Now, condition 2 is at time t is equal to 1 second, velocity is given by velocity, yes, is moving with a velocity which is 4 times the initial velocity. 4 times the initial velocity. That's it. When time t is equal to 1 second, it is moving with a velocity which is 4 times the initial velocity. So, here velocity is given 5 into 4, we have to multiply 20, that's all. So, second condition, when time t is equal to 1 second, velocity, that is initial velocity is equal to 4 times 5, that's equal to 20. So, v is equal to, substitute here, v is 3t square plus 2at plus b. Here v is nothing but 20 is equal to, t is 1 second, 3 into 1 plus 2 into, you know already b value is known, 2a into 1 plus b is equal to 5. So, 20 is equal to 3 plus 2a plus 5. So, this is 20, 3 plus 5 is 8, 20 minus 8 is equal to 2a, 2a is equal to 12, a is equal to 12 by 2 is 6, a is equal to 6. So, therefore, the value of a is equal to 6 and b is equal to 5, that's it. This is the required answer. Let us come to the next problem. Just write on the problem. What is the problem given? S is equal to 4t cube minus 6t square plus t minus 7. Now, differentiate with respect to t. ds by dt is equal to 4 into differentiation of t cube is 3t square. Differentiation of 2t square is t square is 2t plus t is 1. So, this is 4 3s are 12t square minus 6 2s are 12t plus 1. Now, what is required to find velocity when time t is equal to 2 seconds? When t is equal to 2 seconds, velocity is to be determined. That is nothing but ds by dt. What is the velocity equation? V is equal to 12t square minus 12t plus 1. Okay. Now, substitute here. 12 into 2 square minus 12 into 2 plus 1. 12 into 2 square is 4. 12 2s are 24 plus 1. So 12 into 4. So this is 48 minus 24 plus 1. 48 minus 24 is 24. 24 plus 1 is 25 it is. So therefore the velocity is equal to velocity at the end of 2 seconds is 25. What is the unit? The velocity is equal to 25 units. Now suppose if you are requested to find the acceleration, differentiate this. The acceleration is given by the derivative of this dv by dt. That is nothing but 12 into 2t minus 12. So this is nothing but 24t minus 12. At the end of time t is equal to 2 seconds. 24 into 2 minus 12. So this is equal to 48 minus 12. 48 minus 12 is equal to 36 units. If you want to find the acceleration, then it is 36 units. That's it. Now let us come to the next problem. The volume of a sphere is increasing at the rate of 4 pi cc per second. Find the rate at which the area of its surface is increasing when the radius is equal to 10 centimeters. So the volume of a sphere is increasing at the rate of 4 pi cubic centimeters per second, rate at which the area of the surface is increasing when the radius is 10 centimeters. Now just write down what is given here. Given that the volume of the sphere, that is nothing but dv by dt. The volume of the sphere is increasing at the rate of 4 pi cc dv by dt. Find the rate at which the area of the surface is increasing when its radius r is equal to 10 centimeters. Right. Now what is required to find the rate of change of area dA by dt? That's it. Okay. Now you know the volume of the sphere is given by the volume V is equal to 4 by 3 pi r cube. That's it. Differentiate with respect to t. dV by dt is equal to 4 by 3 pi constant. Differentiation of r cube is 3r square. We are differentiating with respect to t, dr by dt. Now first find out dr by dt. Now then we can find out the area. So since dv by dt given, that's equal to 4 pi is equal to 4 by 3 pi into 3 times r. We know r is equal to 10 square into dr by dt. Cross multiply it. So here 4 pi gets cancelled. If you cross multiply this, 3 is equal to 4 pi, you can cancel, divide by 4 pi gets cancelled. 3 is equal to 3 into 10 square is 100 into dr by dt. Now therefore dr by dt can be written as dr by dt is equal to 3 divided by 3 into 100, that is nothing but 1 by 100. dr by dt is 1 by 100. What is the unit? Centimeters per second. Now what is required to find is dA by dt. Now you know the area of a sphere is 4 pi r square. Differentiate it. dA by dt is equal to 4 pi into 2r dr by dt. Substitute, that's all. This is 4 2s are 8 pi r is 10 into dr by dt is 1 by 100. So 10 tens are gets cancelled. 8 pi by 10. So 8 pi divided by 10. Simplify this. If you divide by 2, this is 4 pi by 5. 4 pi by 5. So what is the unit? Centimeter square per second. Centimeter square per second. That's it. See here, very simple problem. Volume of a sphere is 4 by 3 pi r cube. Differentiate with respect to t. Find out dr by dt. So dv by dt is 4 by 3 pi 3r square dr by dt. Since dv by dt given 4 by 3 pi, 3 into r is equal to 10 square into dr by dt, divide by 4 pi. 4 pi gets cancelled, cross multiply. 1 into 3 is 3 is equal to 3 into 100 dr by dt. dr by dt is 3 by 3 into 100, 3 gets cancelled. 1 by 100 centimeters per second is the value of dr by dt. Since we know the area of the sphere is 4 pi r square, differentiate with respect to t. dA by dt is equal to 4 pi into 2r dr by dt. Substitute the value of dr by dt and r. So 8 pi into 10 into 1 by 100. So that is nothing but 8 pi by 10 or 4 pi by 5 centimeters per second is the required answer. That's it. Okay. Let us come to the last problem in this session. So a square plate is expanding uniformly. The side is increasing at the rate of 8 centimeters per second. What is the rate at which the area and the perimeter is increasing when the side is equal to 20 centimeters? This is very important problem for 3 marks. Okay. Let us consider the side of a plate. Let us consider let A be the each side of a plate. Now what is given? A square plate is expanding uniformly. The side is increasing at the rate of 5 centimeters. So what is given? So the side is increasing uniformly at the rate of 5 centimeters. So that is given that dA by dt is equal to 5 centimeters per second. What is the rate at which the area and the perimeter? So dA by dt, area is dA by dt and the perimeter is dP by dt. This is to be determined. Very simple. Let us consider A is the side, each side of a square. Given that dA by dt is equal to 5 centimeters, capital dA by dt, A is the area, dA by dt and P is the perimeter which is to be determined. Now let us find out the area first. Now what is the formula for area? Since we know that area is equal to A square, length into breadth, L into B, that is A into A square. Now differentiate with respect to T. Differentiating with respect to T, dA by dt is equal to, differentiation of A square is 2A into dA by dt. If you differentiate, we will get dA by dt is equal to 2A into dA by dt. Since given A is equal to 20, substitute here. 2 into 20 into dA by dt is 5. So that is, so 20 into 5 is 100 into 2 is 200. So dA by dt is equal to 200. What is the unit? Centimeter square per second. So 200 centimeter square per second is the area. Now then the perimeter, find out the perimeter, that's it. Now the perimeter is equal to 4 times A, that is P is equal to 4 into A. Differentiate with respect to T, dP by dt is equal to 4 into dA by dt, that is 4 into, you know what is dA by dt? 5 centimeters per second. 4 into 5, that's it. Okay. So 4 into 5 means 20. This is 20 centimeters per second. This is the required perimeter. That's it. See here, I'll explain once again. Let us consider A is the each side of a square plate. Then given dA by dt is 5 centimeters per second. And what is required to find is rate of change of area and rate of change of perimeter when each side is equal to 20 centimeters. So area of the square is A into A, that is A square. So differentiate with respect to T, dA by dt is equal to 2A into dA by dt. Substitute the value of A as 20, 2 into 20 into dA by dt is 5, that's equal to 200 centimeters square per second. On the other hand, perimeter of the square 4A. So P is equal to, differentiate with respect to T, dP by dt is equal to 4 into dA by dt. dA by dt is already given. 4 into 5, that's equal to 20 centimeters per second is the required perimeter of the square. That's it. So that's all regarding the problems based on area as well as the square plate and finding the velocity and acceleration. So that's what regarding this rate measure is concerned. So that's all for today's session. Let us meet with a different concept in the next class. Thank you very much.